today I'm going to talk about political biases in large language models from two different perspectives: the evaluation of models and also a little bit of multilinguality as well, and what we have done in our last studies related to that. Okay, well, I understood that you work with AI in society here in this department. I'm very curious to talk to you later about your research. So you might already be aware of the importance of studying political bias in large language models and understanding how representative the political opinions are in large language models. So because people are using them every day more and more, we're going to have these applications in our lives. So the main motivation to start this study was to understand the political biases in LLMs in a more fine-grained way, and also understand how we can evaluate these models reliably. And this is a collaboration with previous colleagues from the University of Stuttgart that I would like to present today. So previous studies had seen, at the point when we started doing this study, a couple of other papers had seen that models reflect more left-leaning or libertarian opinions. However, these studies had not really investigated how consistent these political opinions were within policy issues, for example, in a more fine-grained way. We just knew that they were reflecting more left-leaning opinions, but we didn't know where were these left-leaning opinions. Was it in migration? Was it in economic issues? Was it in environmental? Where was it? Where are those political biases being reflected? So we try to we try to evaluate this political bias in a more fine-grained way in this paper. And for that, we first try to distinguish levels of political opinions. Because, as I said, left and right leaning is much more broader than what actually you can find in terms of political opinions. So we separate into three levels. This is the most fine-grained level called, which we call policy. So as an example, you could see a policy related to citizenship, and two citizens here have different or contrasting opinions about the topic of citizenship. One of them wants or believes that citizenship should be entitled by birth, and another one believes the opposite, that it should not be entitled by birth. And this is a very specific opinion about this issue of migration. Then we have a little bit broader a little bit broader level of political opinions, which we call in this case policy issue. So we have the level in the level of policy issue, we would have the issue of migration or economics, as I said before. And there are several different policies that are encompassed within this level of policy issue. And finally, we have a much broader level, which is the ideological level. In this case, the example is left and right, but we could also have, for example, libertarian and authoritarian as another level of ideology. And this level encompasses several policy issues and several policies. And we try to differentiate in these levels because we wanted to understand where the biases are. So we didn't find at the time any data set available with these fine-grained details to probe LLMs, so to evaluate LLMs. So we created this data set called Probe VAA, which is a compilation of several voting advice applications like Valomat in Germany from 7 European countries. And and we compiled them, and we also further annotated them with policy issues. So in the example of Italy, drilling is necessary to find more energy resources. If you agree with this policy, for example, this would mean that you are more against environmental protection. So we have all these annotations for these almost 240 policy statements. And then, so this is one part of the study that we wanted to investigate, and the other part is reliability. Because these previous studies had not what, in our view, really prompted the models enough to understand that these biases were ingrained in the internal representations, because we have seen by now that, or previous studies have seen that LLMs have suffered from this problem called prompt brittleness. So they are, for example, very sensitive to the position of the token. When you change the position of the token, you might have a different answer already, or the frequency of the token, depending on what target label you use. For example, if you use do you agree or disagree, or is it positive or negative, you might already have a different answer. And also the lexical choices influence on the answer of the model. So we wanted to make sure that these biases are really there by doing a more robust evaluation. And for this part, we create this, what we call the reliability-aware frame analysis, which is a series of tests to understand whether these biases are really encoded in these models. And I can show you now the tests that we have created. So the first one is called the significance test, and in this case, we use exactly the same prompt to ask the LLM about this policy statement, the opinion on this policy statement, and we sample it 30 times, and then we run a bootstrapping statistical approach to understand whether the answers are statistically significant or not, on exactly the same prompt. The second test that we use is called we call the inversion of target label. So if in one of the prompts we say, do you agree or do you agree or disagree, in the next prompt we ask, do you disagree or agree, because the answer should always be the same. And then the last three tests are related to the statement, so to the policy statement from our ProVAA dataset. The first one is paraphrasing, so semantic equivalence would be, we take, for example, there should be an additional text on meat, and we paraphrase this statement 3 times. And again, ideally, we would want the LLM to answer always the same, to have always the same opinion on this topic, on this policy statement. And then the last 2 are related to the negation. So opposite would be finding a semantically inverted opposite version of the same sentence. So there should be less text on buying meat. And negation would be just adding the negation mark in the sentence, or the grammatical mark in the sentence. Yeah, so these are the 3 tests, and these are already the results that we have. So we evaluated at that time, because now things go so fast that these LLMs seem to be a bit old now. But at the time we evaluated Mistral family, Llama family, and Ceron, and ChatGPT. And here it's ordered in parameter size. So the lower it is, or the most bottom here, the bigger the LLM. And what we find is that in terms of significance, even if we use exactly the same prompt, the small LLMs suffer a lot from brittleness, and only 50% of the statements were significant. So meaning that only 50% of the statements had the same answer when doing the statistical test. Whereas the bigger LLMs like ChatGPT and Llama 70B were more reliable. Also in this case, Llama 13B, more reliable in this test. Then the inversion labels test was the best performing one for the LLMs. We can see that most of them performed really well. So always answering the same stance, almost always answering the same stance, even though the labels were inverted, except for Llama 7B, which was relatively unreliable in this test. Then for the statement variation, so we evaluate, actually we wanted to understand how reliable humans are also in this statement variation test. So we sampled 50 questions from the ProVAA and also gave it to humans. So they had to answer I agree or disagree to the original statement, the paraphrases, the negation, and the opposites. And first we look at the results of the humans here. This is the coherence kappa between the original and, for example, the opposite. And we already expected that humans would be very reliable in the paraphrases of the policy statement, a little bit less reliable in the negation and opposite, because sometimes it's, if you read in terms of policy statement, it's really not exactly the opposite. It could mean something else. That's why actually we wanted to test also on humans. But it's still 0.7, almost 0.7 is not, is relatively high as the coherence kappa. What we see is that in the models is that models such as Luma 70B, which is the most reliable one, performs almost like, or performs, or is as reliable as humans in the paraphrases. However, as this is a well-known problem in, I don't know how familiar you are with computational linguistics, but there is a problem in understanding the negation of sentences. This is like, it has been like that for years, and we can also see that in LLMs that they are way less reliable when we test them under the negation in the opposite tests. Okay.
Question about the previous slide.
Yep. This one or
the next one. So about a year or two ago, there were papers claiming that existing models were not good at handling negations. So how can we distinguish the effect of bias from that of simply the models not performing well, like performance versus bias?
In this case, the only thing that we test here is the reliability of the models in answering the same when answering the original statement and the negated statement. So this is not related to the bias. This is just to understand how reliable they are under different prompt formulations. And then we take this into account later, because we actually exclude the statements where the models were not reliable in these tests. So we basically don't analyze these statements that didn't pass these tests.
I have a small question on the human baseline. So first, what's the pool of humans, but then also, what was the setup? I mean, would you ask the original question and then immediately the negated question, or sort of there's some time between so that I can actually forget or something, or like what's the thing?
It's a good question. It's randomized. We have randomized the originals and all together, so this 50 and all the 50 that are the opposite negated, but they are all randomized, and the students who participated in the survey, they have to go one by one. They cannot go back. So that was the method.
Yes.
I'm sure that social scientists would have probably a little bit more controlled way of doing this. But they were not allowed to see back the statements.
I just wondered if you had any issues with the language models sticking to the task. So sometimes you prompt them to classify something, and usually they do what you want them to do, but sometimes they give you a whole essay about why they've made a particular choice and so on.
Mm-hmm.
I had that issue with Mistral in particular, so I'm wondering if that might explain something of the lower score there, or maybe not.
Actually, so many people already asked me this question, because
really?
apparently they have this problem, but we didn't have this problem. I think less than 5% of the statements were rejected, like the model rejected to answer something about it. And my hypothesis for that is that we were asking very fine-grained questions about policies, and not questions that could raise the safeguards of the models, like more related to gay marriage, gender. Well, there were a few questions related to gender, but they were so related to law regulations. I think that the models just didn't pick up as something that they could not or they should not answer. So I know that many people who worked with the political compass dataset, I don't know if you know this dataset, it has more ideological questions related to gender, race, same-sex marriage. In this case, they always had this problem of rejecting to answer, the model reject to answer. And I think it's just because they are clearly more connected to the safeguards of the models. That's my hypothesis at least. And I talked to my colleague who also works a lot with safeguards and LLM safety, and he also thinks that this is not the most likely explanation for that.
Maybe with classifying toxicity and things like that as well, it might be a similar. I
don't know if this relates that, but these models have been post-trained to be very helpful and very harmless, right? So some topics in particular they have learned really well in this post-training process, and they are this more, they are usually topics more related to human rights. Or things that you are sure that the model doesn't, you don't want the model to say like something sexist, for example, or something racist. So they really trained the models, in the post-trained the model to not say anything about it.
Sure. Okay.
But unfortunately, one of the open questions is what data is used for post-training, because unfortunately most of these models are closed, so we cannot have access to the post-alignment data, even though we more or less have an idea of what they might have used for the post-alignment. Now we have OIMO, so as a side project, I'm trying to work with OIMO data because it's the only one available. So then we did a higher level analysis of the political positioning in terms of left and right. So going back to the pro-VAA, we also have the answers of the parties. For example, for Wahlomat, we have the answers of the German parties. So we have binned the parties into center parties, right parties and left parties, according to the Chapel Hill survey, if you are familiar with it. It's a survey from political scientists where they define the positioning of parties. And then we see, we only, in this case, as you can see the percentage here, we only use the statements that have passed all tests. So maybe I actually skipped this slide because I was answering the questions, but this is basically the mean of the statements that passed all tests. And we can see again that Mistral 7b, the smallest one, is the least reliable one, and the biggest one is the most reliable one when prompting under these different prompt formulations. So we only use the reliable statements, and we see that again what was seen before already, that models we see the percentage of answers that align with the left-leaning parties, the right-leaning parties, and the center parties. And again, as a tendency, of course, we have that statements align more with left-leaning parties, much less with right-leaning parties. But because now we have this data set which is European, so we can also analyze center parties in comparison with the US context with only left and right. We can see that also models are relatively well aligned with center parties as well. And then we have this more fine-grained analysis of within the policy issues. This is a spider web that represents the stance of the models towards these policy issues. So the closer it is to the edge here, the more it agrees with this policy issue. And the closer it is to the center, -1, the more it disagrees. But you can see that actually it's either 0, which means 0 for us, it means that it has no stance towards this, because it has not been it has not answered consistently either in favor or against. So there is 0 is no stance. It's not neutral, it's just not consistent, basically. And we see here I have the biggest models, so the ones that were most reliable, even though actually the spider web, if you look at the paper where we have all the spider webs, the political biases are similar across models, if you look at all of them. And what we see is that models are more in favor of environmental protection, social state welfare, and liberal society, which are indeed more aligned with the left-leaning agenda of parties. But interestingly, we can also see a slight tendency for law and order in both both models. Slightly also for restricted finance related to taxes in this case. So it's about restricted finance in this case is spending less money from the government. And liberal economy also has like tendency, which are three policy issues that are more related to the right-wing agenda. So in the end, we see that these models have definitely more liberal ideas, or not maybe more actually progressive ideas in this case. But they also, if you look at the fine-grained policy issues, they might have some right-leaning tendency as well. Yeah, and this was it for this part of the study. If you have any questions?
Maybe just a related question. You mentioned that -1 is missing data rather than neutral. So where's neutral? I mean, like, I didn't quite understand it.
So -1 would be against this policy issue, or the closer it is to -1, the more against it is. And 0 would be that sometimes it said I agree, sometimes it said I disagree, and then when we aggregated the answers, there was no clear stance.
I see. And if it always said something in the middle, I sort of agree, would it also be 0? I mean, 0 is both like left and right, as well as always center, or is there like
I sort of agree is not possible for us because we have this way of evaluating which is binary. So do you agree or disagree?
I see.
So these are really interesting results. I just want to understand a little bit more. If I read it correctly, it seems like it's something like a bit of an FDP position, maybe socially liberal and economically conservative. Could you read it that way? And whatever maybe the positioning, how do you explain these results? Is it something in the training data? Because that's fair, at least for political parties, that kind of position is fairly unusual. Why do you think there isn't a more typical balance of policy positions that you find?
Unfortunately, I don't have a clear answer for it. I only have a hypothesis because we have not investigated the pre-training data or the post-training data. It's something that we are doing now in another project. So hopefully soon I will have better answers for that. But for now, one of the hypotheses for the first one I would say is that these three topics here, they are also related to the topics that are used for post-aligning with for harmlessness. So again, they are topics, for example, that are related to let's say some specific questions about same-sex marriage, specific questions about like renting rights. Renting rights would be too specific maybe for safeguards. I think not in this direction, but marijuana legalization, abortion, all of that, for example, would be related here to liberal society. And one of the hypotheses that in the post-alignment they were using data that was more progressive because it was the type of data that would also go in line with human rights. This is just a hypothesis. It's not sure, unfortunately, because we don't know how they selected the data. There is no information whatsoever about their post-alignment data. We don't know it. Also, environmental protection, for example, like it's difficult. Like, people would not want the model to say let's really destroy forests, for example. So I imagine that this was also part of the post-alignment because you don't want the model to say this type of to have this type of discourse. This is again hypothesis.
Sure.
In the data set, does it contain some of the samples? Let's say, does it contain demography information? Because what I have seen in my own research is that whenever you include demography information, depending upon the countries, and if they so for instance, if the country is let's say a conservative country, then their opinion about more liberal cause becomes a bit more restricted in a sense. So do you think that this is also addressed in this one? So I think so that is one, and secondly, does adding those demographic informations also changes models output in general?
So we have not evaluated for demographic information. Everything that we asked was without any type of persona. So unfortunately, I cannot answer you this question, but I have seen very contrasting. So I have seen papers where they worked with that, and the results are not so clear of how much, like, the model doesn't always consistently change towards the demographic that you add. Again, it might be a problem of prompt brittleness. It's difficult to say, but what was your experience like? Did you feel like the model was really changing towards the direction that you wanted to change?
So for instance, I think so if you talk about, let's say, same-sex marriages, I think if you take a like conservative country, then so I was experimenting with sympathy that the society shows towards let's say some crime committed against these communities. Then I think the level of sympathy that so the prompt was basically how much sympathy would they earn in a scale of, let's say, 1 to 0. Then I think so that do change over how, depending on the society they're actually present. I think so. Yeah, that's it.
It can also be that because I think so. These the studies also that I have seen were with previous models. What I noticed, because I actually reran the reliability tests in the newer version of Llama, like Llama 0.1, and also the older versions, which were like Mistral, the newer version. And smaller models are. So one thing is that the smaller models are nowadays more reliable than the results that a little bit more reliable than what I got in the test. So I think this is a problem that probably companies are aware of, and they're doing something in regards to that. So I could believe that maybe because there is so much done on persona nowadays, I could believe that they have also tried to stir the model somehow more into the personas that you're using, because it's very reliable. I mean, there are many use cases also for companies, for surveys, where people are investing a lot on LLMs being stirred by these personas. So I could imagine that now they're more reliable in this sense as well. But I have not seen any very recent paper about it, so I don't know.
Thanks.
But my idea is that yes, the companies are definitely aware of this problem of reliability and and especially of personas, because there is so much interest now in trying to prompt the model with a persona that will give you the answer of the survey. And, this is again, unfortunately, like working with these models is a bit frustrating because they are all closed. So we only raise hypotheses. Hopefully, in the future it will be better. That's my hope, at least. So this is another study with my colleagues from Stuttgart and St. Sebastian, and we want to understand how these political biases change across languages, or when prompting models across languages. And why? Well, first reason is there is very, very little data which is non-English being used for training these models. So it can be that these models are very influenced by English, but we still don't have enough research to say anything related to that. And the other reason is, so this is, or the other motivation for this study is that countries have a slightly different opinion, or a slightly different political leaning. So this is a research on global opinions survey called the Global Opinion Survey from 2023. And you can see that countries is likely change, like on average, if you take the average citizen in these countries, the political leaning will slightly change from one country to another. So is it, if we consider the average citizen, is it also reflected in LLMs or not? So we start with hypotheses about how these political biases are encoded across languages. And the first hypothesis is that, the political opinions transfer between languages, which means that political bias will be always the same. And the other hypothesis is that they don't transfer, so they have separate opinions across languages. And for that, unfortunately, in the first only by probing the models, the vanilla models, we cannot really know whether the prediction, because it can be that the political opinion is the same, because maybe the data that was used for each country was the same, etc. So we could have, in this case, two possibilities. The first one, that the models have the same opinion, and the second prediction is that the models would have different political opinions for this hypothesis. That's why we do like a second part of this study to try to disentangle these predictions, which was to align the models politically with English data. So in this case, if hypothesis, we use English data to align the models for more left-leaning opinions or right-leaning opinions, or like right-leaning position. If hypothesis 1 is correct, we are going to see that all the opinions are shifted across languages. If hypothesis 2 is correct, then only the English will change in this case, and the other languages will remain the same. Okay, so for this experiment, we actually use exactly the same method that we used before. We just now use other languages. I didn't mention, but in the previous study we only used the English. So we translated all the policy statements to English and only used the English language. And now we translate all the statements to Spanish, German, French, and Italian, and also probe the models in those languages. We evaluate over 15 multilingual LLMs, but here I'm only showing the results of the ones that were most reliable, according again to those tests that we have used, which are AIA, GPT, Command R, Llama, and Phi. And what we see is, so this is a regression analysis showing the difference. So when we consider all these models here, so all the most reliable models, and we try to understand, well, in this analysis we want to understand if the difference of the, in this case, of the political stance significantly changes across languages. So what we see here is when you see that there is, it's a bit, how to say, opaque, it's a bit opaque, it means that there is no difference. So the political stance across languages when comparing to English doesn't change. This is in terms of left and right. Then what we do see some difference is when you go in a more fine-grained analysis. So when you go, for example, in environmental protection, there is a slight difference between English and the other languages, in this case, German, Spanish, and Italian. But again, the results are like the difference is very, very small. This is not about, by the way, this is not about the leaning, the absolute leaning, but it's only the difference with the English language, right? For this case of law and order, there is no, I mean, the difference is not significant, so we can say that in the case of law and order, the languages, the political opinions across languages is the same. Here in this experiment, in this part of the results, we see the difference across models. I cut the heading, but this first one was on political stance. Again, we see that, so this is all, in this case, compared to Mixtro 7B, and in terms of political left and right positioning. Again, there is a slight difference between these models, or at least all the models except for Llama 8B and Mixtro, but the difference is very small. There is a higher or a larger difference between the stances of, in this case, just to go back, the environmental protection in the models in comparison with Mixtro. This is interesting because, like, these models are from different families, and they might have used different data for post-alignment. So again, my hypothesis is that these biases do come from post-alignment, and especially we can see it when you compare across models, there is a higher difference. The same for, just to remind you, law and order. We can see a bigger difference in the positioning of law and order across models in comparison with strong. So just to say about I don't know how familiar are with the training of the models, the pre-training data and the or the pre-training and post-training, but for the pre-training, I mean, there may be a difference in the pre-training and post-training across models, but we know for sure that for the pre-training data, the data that all companies use comes from common crawl, so they come from the internet. We just don't know exactly how they filtered this information, right? Because they might have used different filtering techniques, and this leads to having different information in this data that is used for pre-training. To reiterate on that, it could be either coming from the pre-training data or from the post-training alignment. We don't know. Okay, so this is not clear yet. So what we see here is that in terms of political leaning of left and right, they are very similar. So we can still not validate either of the hypotheses. So we do a second part of the study, which was to align the models, the vanilla model, to left-leaning views and right-leaning views. We use data from the Manifesto project, if you're familiar with it, where every sentence of manifestos, or many manifestos, have been annotated by the sentence level, with categories from their codebook, which can actually be very specific. So, for example, here is one sentence of the manifesto, which has been annotated as military positive. And we use these labels to map to our labels, which were related to policy issue. So in this case, military positive for us is considered in favor of law and order. And then we use these sentences that have been mapped to this new category. And then we also say, okay, this is representing left-leaning, these labels are representing left-leaning opinions, and these are representing right-leaning opinions. And then we take 5,000 sentences with these annotations, and we post-align the model using direct preference optimization, if you are familiar with that. And the results. So here are the results of the vanilla model. So in the case of the vanilla model, we see that this is the stance of being more left and more right being one. We see that the vanilla model, as we had seen before, has this left-leaning tendency in most policies, except for, in this case, the law and order is a bit more more center than left, let's say. If we compare, so this is now the result, the comparison between the vanilla model and the left-aligned. What we see here in the left-aligned model is that the stances don't really change. So our hypothesis is that the model is so left-aligned already that by just giving more data that is left-related doesn't cause a lot of effect in the model. However, if you look at the right-aligned model, we see that the model does change its stance. Actually, it's surprising. We thought it was surprisingly a lot, because we only post-aligned with 5,000 sentences from manifestos. And we see that now in all policy issues we have a more right-leaning stance here, especially in the case of social welfare state. The model has changed a lot more, especially for English. But this was, so the bold line is the only one that was significant across languages. So the only one that has changed more the political opinion across languages was expanded the policy issue of social states of welfare. The others have changed more or less the same as in English. So this leads us to think that hypothesis 1 is the correct one, because in most of the cases, except for social welfare state, we have political opinions that have changed across languages. So our idea is that opinions do transfer between languages, even when we post-train only with English. Okay, so our final question, I'll explain this quickly, was we have seen, interestingly, that these models actually right align or left align if we do this post-alignment to this scenario where we probe the models with do you agree or disagree? So it's a binary classification test, basically. We wanted to understand whether the models also change their opinion in another type of downstream task. So we asked these models, the vanilla, the left aligned and the right aligned, to write a opinionated short statement on topics that are related to the policy issues where we saw a significant difference in the alignment. So for example, write an opinionated short statement about privatization or about universal programs. And we try to understand, and then we run a stance detector to understand whether the model changes its opinion also when writing a text, which means that these biases are being reflected also in other types of tasks that we users use every day as well. And indeed, it does change, basically. So you can see that the green color here is the left aligned model, the bars are the left aligned models, the yellow are the unaligned, so the vanilla models, and the lavender is for right aligned models. You can see that the tendency, now you can forget about the languages, but the tendency is that it always goes down here, meaning that we see a difference in this tense when writing opinionated text. So the right aligned in the terms of score here means that it's very in favor of policies that are in favor of environmental or are in favor of the environment. And then when we analyze the right aligned model, it has changed a lot, even though we have not asked the model we have not prompted the model with a stance. We just asked the model to write an opinionated article about a statement about this topic. So the tendency is that it goes down, meaning that it becomes less left aligned. Again, so another detail is that this is the left score. It doesn't mean here that the model becomes completely right aligned, because except for the case of microeconomy, the rest actually the score is still more in favor than against. That makes sense. Yeah, and the other result here is that it doesn't change much. I don't have stats about it here, but there is the bars are pretty similar across languages. So it doesn't. Again, it just proves that there is not a big difference across languages in terms of political opinions. So, well, the takeaways here is that it's very important to analyze or to evaluate models robustly, and it's also important to have to evaluate, in this case, the fine-grained policy issues and not only this high level of left and right. And that political biases are carried over across languages, and that post-alignments. So our intention was not to, the objective of this paper was not to look at post-alignment specifically, but another interesting finding is that very few sentences can post-align the model to a different direction. In this case, we have a model that is more right-leaning. this is the, I don't know if you have followed the statements from Meta, but they have said that they are going to align their models differently now to more conservative ideas. So it is, we have seen that it is possible to do that. The question is, what are they planning to do and how are they going to do that now? And there is a lot of further research in this area. So for me, political biases are very interesting because they have not been studied before Gen AI. So for these generative models, there used to be only research on usually gender bias or race bias at most, or ethnical biases as well. But with this generated texts, we can see some biases reflected also in terms of political opinions. So this is a complete new area of research. We need to understand where these biases come from. We need to understand how they are reflected in downstream tests like summarization, for example. I wonder if this is still an open question of is there any type of selection of the model when summarizing texts in terms of going more into the direction of left or right. So this is some type of selection of information, of gatekeeping of information, and we need to understand how this works and also what to do with that once we understand the biases. Yeah, my final question for you all, which is very difficult to answer, I think, is what type of political worldviews should these models encode? There is this paper from last year which has become quite famous with some approaches on how to align the models to pluralistic opinions. So technically they have some solutions for that. So for example, you would align the model with all the opinions, or you would stir it towards the opinions of the user, or you would have a distributional sampling of answers according to a certain population. But I do think that this paper doesn't answer, and I think there is the need of a lot of research from the ethics discipline. I mean, disciplines that touch on ethics also, or philosophy or psychology to understand, or social sciences, to understand exactly how these models should behave, or normatively, what's the best way of designing these models that will align to our democratic values at least. Yeah, so this is basically what are the possibilities for representing different opinions. So should we represent all the opinions, or should we have something personalized? Or what I believe we have currently, which is this one-size-fits-all model, so representing certain opinions that are more predominant in the training data or in the post-training data. And